Trigonometry. In this session, we'll see how to derive formulas for sin 2 theta, cos 2 theta, and tan 2 theta. 2 theta means it's a multiple of a angle theta. For any angle theta, 2 theta, 3 theta, 4 theta are called as multiple angles, and so these formulas are called formulas of multiples. Now, when we know the value of sin theta, that can be used to find the value of sin 2 theta and sin 3 theta, and so on. Similarly, from cos theta, we can find cos 2 theta, cos 3 theta, and so on. And using tan theta, we can find tan 2 theta, 3 theta, or 4 theta, whatever. For that, before finding these values, we have to be familiar with the Ptolemy's sum and difference formulas. These are the four formulas that are required in the derivation. So this sine alpha plus beta, cos alpha plus beta, sine alpha minus beta, cos alpha minus beta. Angles can be represented using any letter or like this using alpha, beta, theta. So this is just to tell that it's a specific angle. For deriving sine 2 theta, we will use the formula for sine alpha plus beta. Sine 2 theta can be written as sine theta plus theta. 2 theta is divided as theta plus theta. Here if we compare this with the original formula, in place of alpha and beta, we have theta values. So we'll just try to substitute alpha and beta with theta in the original formula. So this is the original formula. We are writing here the values of alpha and beta. So that will modify the formula like this. Cos theta, sin theta. Now this first term and second term, if we see this, it is like AB and BA. We know that AB is equal to BA. That is the property of multiplication. Using that, we can tell that these two terms are same. When we add two similar terms, we can write it as 2 times the term, that is 2 sin A cos theta. So this sin 2 theta can be written as 2 sin theta cos theta. This is the formula. To verify this formula, we can just substitute theta with any value. Here, let us try substituting theta with 30. Now, if you substitute 30, what will happen here? Sine 2 in place of theta 30 is equal to 2 sine 30 cos 30. So 2 into 30 is 60. So this becomes sine 60 equal to 2 into, we know sine 30 equal to 1 by 2 and then cos 30 equal to root 3 by 2. These two will get cancelled and this gives a result of root 3 by 2 is the value of sine 60. So here we found the value of sine 60 using sine 30 value. In this way we can use the formula to find the value of 2 theta when we know the value of theta. Now let us derive for cos 2 theta. For that we have to use cos alpha plus beta formula. Now cos 2 theta can also be written as theta plus theta. Here again we have both alpha and beta equal to theta. So from the formula we will just try to substitute the values of alpha and beta. Is equal to, in place of alpha it is theta, again in place of beta also we have theta. So the formula will get modified like this. We are using this formula and substituting the values. So cos theta into theta is nothing but cos square theta and sin theta into theta is sin square theta. So this gives the formula for cos 2 theta, which is equal to cos square theta minus sin square theta. Now also we can verify that theta is equal to 30. Now just substitute this. So this is nothing but cos 2 theta. So cos 2 into 30 equal to cos square 30 minus sin square 30. Cos square 30, cos 30 is nothing but root 3 divided by 2. We are going to take whole square minus sin 30 is 1 by 2 whole square. So 2 times 30 means it is 60. So we have cos 60 is equal to root 3 by 2 whole square means 3 by 4 minus 1 by 2 whole square means 1 by 4. Here 4 in denominator, so we can directly separate the numerators. 3 minus 1 gives 2 divided by the denominator 4. This is nothing but 1 by 2. So cos 60 is equal to 1 by 2. We are able to derive the cos 60 using cos 30 value. Now, the same formula can be written in other ways. For that, we have to know that sin square theta plus cos square theta equal to 1. Now, if we rearrange the terms here, we will just try to transpose sin square theta to the other side. That makes cos square theta equal to 1 minus sin square theta. We'll substitute this cos square value where it is 1 minus sin square theta, and this one comes as this, that is minus sin square theta. So these two are similar terms, so we can write it as 1 minus 2 sine square theta. So cos 2 theta is also equal to 1 minus 2 sine square theta. Not only in this way, we can use another way also. In this case, we will just try to transpose the cos square theta to the other side. That makes sine square theta equal to 1 minus cos square theta. From the formula here, cos square theta we will write as it is. In the place of sin square theta, we will try to substitute this formula, that is 1 minus cos square theta. This is equal to cos square theta. Taking minus inside makes minus 1 plus cos square theta. These two are similar terms, so it is 2 cos square theta minus 1. This is the third formula for cos 2 theta. We have got three formulas for cos 2 theta. That is, first one is cos square theta minus sin square theta, then 1 minus 2 sin square theta, and the last one is 2 cos square theta minus 1. Now we already know how to find sin 2 theta and cos 2 theta. We will see for tan 2 theta. For tan 2 theta, either we can use the formula of tan alpha plus beta. This is the formula for tan alpha plus beta. Or we can derive them using sin 2 theta and cos 2 theta. In both the cases, we will get the final result tan 2 theta equal to 2 tan theta divided by 1 minus tan square theta. Now we will try to use this. We will have both the alpha and beta equal to theta. So when we write that, it becomes tan theta plus theta is equal to, in place of alpha we are writing theta, again in place of beta we will write theta, divided by 1 minus tan theta, again tan theta. In the numerator, these two are similar terms, so we can write 2 times tan theta whole divided by 1 minus, these two are similar, so we can write it's a product, so it's like tan square theta. So tan 2 theta is 2 tan theta divided by 1 minus tan square theta. This is by using the formula of tan alpha plus beta. We know that tan theta equal to sin theta by cos theta. Using that, tan 2 theta can be written as sin 2 theta divided by cos 2 theta. Just now we found these values of sin 2 theta and cos theta. We will just try to substitute those values. Sin 2 theta is nothing but 2 sin theta cos theta. Cos 2 theta is 1 minus 2 sin square theta. Now we'll try to divide both numerator and denominator with cos square theta. So this entire time divided by cos square theta and the denominator divided by cos square theta. Now we'll do like this. The numerator first, 2 sin theta cos theta. Cos square theta is nothing but cos theta into cos theta. So these two will get cancelled out and we will have 2 sin theta divided by cos theta in the numerator. In the denominator, 1 by cos square theta minus 2 sine square theta divided by cos square theta. Now here sine theta by cos theta is tan theta, so we'll write 2 tan theta. We know that 1 by cos theta is nothing but sec theta, so this particular term can be written as sec square theta minus sine by cos is tan, so this becomes 2 into tan square theta. In the previous side, we have seen that sine square theta plus cos square theta is equal to 1. From this, if we divide both the sides with cos square theta, cos square theta, then this formula will get modified as tan square theta plus 1 is equal to sec square theta. This sec square theta, whatever we have got here, we will substitute in the denominator. So the numerator will remain as it is, and in the denominator, in place of sec square theta, we will get tan square theta plus 1. And the next term will remain as it is, minus 2 tan square theta. Now, on further simplifying, 2 tan theta divided by tan square theta minus 2 tan square theta will become minus tan square theta. It is nothing but 1 minus 2. So, 1 minus 2 is minus 1. So, minus tan square theta, and this one we will write as this. So 2 tan theta divided by 1 minus tan square theta. This we have derived using the concept of tan theta is equal to sin theta by cos theta. So we have seen two different ways of arriving formula for tan 2 theta. If we observe in the both cases, it is same. In this video, we have seen how to derive formulas for sin 2 theta, cos theta and tan 2 theta.